So, who of you had this situation in the past that you sat in front of your computer, you had to implement something, and you thought, well, I can't be the first one who has to implement this? Yeah, I know the situation all too well. And that's the same for the readers of my blog. Over the last few years, I got probably hundreds of questions asking, isn't there a feature in Hibernate that can do this, or what's the easiest way to do that? And luckily, there are quite a few features in Hibernate that allow us to implement certain things with a simple annotation or by implementing an interface. So, who am I? I'm Thorben Janssen. I'm spending most of my day solving Hibernate and JPA problems by doing consulting, coaching, speaking at conferences. I wrote a book. And yeah, most of the times I'm showing people how they can either solve their performance problems with Hibernate or how they can easily and quickly implement a certain thing with Hibernate. And that's what I want to do today. So let's not spend any time on slides, just get into the IDE and try a few things. So one of the most common questions that I get is, how can I understand what Hibernate does internally? Which queries does it create? How long does it take to execute these queries? And okay, I know you can go to the database and check the logs there, but you can also ask Hibernate. Hibernate has an internal component that collects statistics about the session. And it's obvious. Hibernate knows pretty well what it is doing. You just have to activate the statistics component and it tells you about it. But please don't activate it in production. It takes some time to collect all these information and provide them. So this is only something that you should use in your development environment or on test systems. So what do you have to do? You have to set the Hibernate.generateStatistics parameter to true. That activates Hibernate statistics component. And you should also set the log category, the log level for the category Hibernate.start to debug. And if you do that and run this simple test case here, which just selects an author entity by ID, you can see that you get a lot of additional information that you normally don't get. First of all, this block down here. It shows you how many JDBC statements Hibernate executed and how much time it spent on that, or how it interacted with the second level cache. So let's say you see here that you executed a few JDBC statements, but that took quite a while. So what's the next question? Well, which query was slow? And Hibernate tells you about that. See up here, the query that we executed. The time that Hibernate spent executing the query, which is 36 milliseconds, and the number of rows. And you see that for all queries that Hibernate executed within the session. So you now have all the information within your application log that enable you to improve your code and or at least find out which database query was slow and then talk with your DBA about improving it. Well, if a query takes a while to execute, then you quite often perform the query that returns a lot of data. Let's say a few thousand rows. And one way to fix that is use pagination. The client doesn't need thousands of records anyways. And I'm always surprised that I then often get the question why Hibernate doesn't support that. Well, it of course does, but it does that in a different way than you're used from SQL. With SQL, you provide a limit and offset clause here in the query, but JPQL doesn't support that. But the query interface provides you two methods to do exactly the same. You can set the max results and the first results, which are translated into a limit and offset within the SQL query. You can see that here when I run the test case. So this one starts with the 5th record in the result set and returns the following 5 records. You can see that here, limit and offset. Another thing that quite often becomes a problem with JPQL queries are joins. JPA and Hibernate make it incredibly easy to join 2 associated entities. But what happens if you didn't model the association between these 2 entities? With SQL, you can join any tables, you just have to define the join clause. But you will most likely not model all possible associations between entities. You model just the few that you need within your model. Unfortunately, JPA doesn't allow you to join entities without a modeled association. But Hibernate does, with a syntax that is pretty similar to the one that you know from SQL. So you can just do this. I select the book, and then I said inner join. I could also do an outer join with the review, and then I define how the joins should happen. And Hibernate translates that into the SQL statement that you probably expected. It's a simple join. Unfortunately, it's not supported by JPA, but Hibernate allows you to do that. Another thing you might want to do, at least in smaller applications that are just used internally and doesn't have to serve hundreds of parallel users, you might want to map the result of an SQL snippet to an entity attribute. In this example, my author entity persists the date of birth of the author. I mean, it's obvious that we don't want to store the age. No one wants to update that on a daily basis. So I'm just persisting the date of birth, and then I use a formula annotation with this native SQL snippet to calculate the age based on the date of birth. And the age becomes a read-only entity attribute that you can then use within your business code. Let's have a quick look at the query. Where is it? Here it is. So Hibernate simply adds the Hibernate simply adds the SQL snippet that are defined in the formula annotation into the SQL query that it executes to get the query from the entity from the database. But be careful, it inserts this native snippet in each and every query that selects the entity. So please make sure that you only use it if you really want to use this attribute in all, or at least almost all of your use cases. If you don't need that, then it's better to move that part of logic either into your business code or to use a use case specific JPQL query and call the functions there. Another thing you find in a lot of applications are views. Views are a common approach to present data in a different way to the user that uses your database. And you can work with them in the same way as with a normal table. I mean, if you execute a select statement, it doesn't make any real difference if you're selecting data from a database table or from a database view. But there is one difference when you are working with views. Depending on the way how you designed your view and which database you use, you might not be allowed to update the view. So in this case, you should also tell Hibernate about that. And you can do that with this immutable annotation, which basically tells Hibernate that it can ignore this entity for all dirty checks. So let's give it a quick try. So here's a test case. I select the view, and then I change the title attribute, commit the transaction, and read the view again. You can see here in the first session that Hibernate executed a typical SQL statement to retrieve the entity from the database. What it didn't do was perform on the update statement, because I annotated the entity with immutable. Unfortunately, Hibernate doesn't throw any exception or tells me in any other way that it just ignored the changed attribute. So if you annotate your entity with immutable, please also make sure to not implement any setter methods so that no one can change the entity. Another thing that you might want to do, especially in smaller applications where the focus is on just getting stuff done and where you don't have to implement that many use cases, is ordering the elements of your association between the entities. Here's a simple example. I have a book entity and an author entity, and a book can be written by one or more authors. So I might now say, okay, I always need my authors in alphabetical order. And I can define that with this order by clause and provide the order by clause in the same way as I would do in a JPA statement here. And as you can see, when I run the test case, Hibernate adds this snippet to all queries that fetch the associated author entities, and I get them in the alphabetical order. You can see here at the end of the query that we have the same order by clause that are defined in the annotation. Again, be careful with this feature. It can be a quick and easy way to add the ordering, but Hibernate will add it to all queries that initialize this association. So it might become a performance problem if you not need all of the authors always in the alphabetical order. And in the formula example, I used a database function that is not part of the SQL standard. And Hibernate supports a lot of database functions, even database-specific ones using its database-specific dialects. But there are still some database-specific functions that are not supported, and you or your DBA might implement your own database functions. So what do you do with these functions? Well, you can do two things. You can either register the function in your own Hibernate dialect, or you can use the JPQL function called function and call any function you want with this expression. So this one calls the function calculate and provides the price of the book and the bind parameter $1 as parameters to this function call. And when you take a look at the generated query, you can see here that Hibernate transformed that into the function call, named function, the book price, and a bind parameter value. When you're using that with Hibernate, you have to be a little bit careful. That works perfectly fine in the where clause, but if you want to use that in the select clause, you have to do a little bit more. You then have to register the function, because Hibernate needs to know the return type of the function, and it doesn't get that just from the function call. Another thing I want to show you is the JPA Meter Model. Who uses the Meter Model, or at least knows about it? It's a nice little JPA feature. And you can see one of the Meter Model classes here. So with the JPA Meter Model, you can tell your persistence provider to generate an additional class for each entity. And this class has the same name as the entity with an added underscore at the end. And that is the important part. It has an attribute for each attribute of the entity. So you can then use it in your criteria query, for example, or when you define entity graphs or do anything else where you need to reference an entity attribute. You can use also the JPA Meter Model attribute and reference the attribute in this way. That has two main advantages. First of all, it's way more comfortable to implement because you don't have to remember the name and type it correctly for each attribute. But the even bigger advantage comes into play when you need to refactor your entity. I mean, what do you normally do if you refactor entity attributes? You change your entity, and afterwards you use your IDE to search through all defined query strings to find the places where you reference that entity attribute and change it. And in the end, you hope that you, first of all, found all, and then that your test coverage is good enough to find all the places that you didn't change or that you changed incorrectly. If you use the JPA Meter Model, then the next compile run of your project will update the Meter Model class. So when I change the author attribute from first name to F name, then it gets also changed here, and you will get a compile error for this statement. Sure, not as good as from a point of not as good as a tooling as we probably would like. I mean, it would be even better if it would automatically update everything, but we at least get a compile time error for all places where we need to adapt our query code to the new entity attribute, and that saves a lot of time and avoids a lot of problems when we roll out the update. Primary keys. Who of you uses UUIDs as a primary key? Okay, not that many. You can, of course, use a numerical primary key as most applications do. But depending on your application, it might make sense to use an UUID. It has the main advantage you don't need a database connection to generate a unique ID. You don't run into any scalability issues because you don't have the one system that needs to manage and provide the next numeric value. Because a UUID is pretty unique by definition, and you can generate it basically everywhere. So you can use it, for example, if you have a system with an offline client. And the offline client can store all the information in a local database, generate its own UUIDs, and as soon as it gets back online, it can then transfer all the data into your main system. So you can, of course, generate the UUIDs in your Java code, but you don't have to. You can also tell Hibernate to generate a UUID value. And as long as you follow the default approach, which is a random number-based UUID, it's incredibly easy to do. You just need an attribute of type UUID and annotate it with generated value. That looks basically the same as your numerical primary key. The only difference is you use a UUID class instead of a long. And Hibernate takes care of the rest. You can see here, Hibernate tells us it generated a identifier, a nice looking UUID. It's probably unique as it looks, and it used the UUID generator for that. Okay, now you don't need to use a random number-based UUID. You could also use an IP and timestamp-based approach. And if you want to do that, then it takes a little bit more effort, but you can also do that with Hibernate. You can see the required annotations here. Now I'm not using the default, that means I need to define more. And that means I need to reference a generator and define it with the generic generator annotation. And as you can see here, then using the UUID generator strategy, and the important part is the parameter annotation down here. So here I tell Hibernate which UUID generation strategy class it should use to generate the ID, and that is the custom version 1 strategy, which is an IP-based approach to generate primary keys. When we now run the test case, then you can see that Hibernate now generated a different UUID using a different algorithm. But in the end, you still have your UUID without the necessity to implement it yourself. Hibernate already provides a good implementation for that. Okay, the next one is a popular question since the introduction of Java 8, so for quite a while now. Have you ever tried to map an optional association, for example, to an optional with Hibernate or with JPA? But it doesn't directly work. The issue is optional isn't supported as a data type. And there are good reasons for that. One of them is that optional is not serializable, so if you would use it as an entity attribute, you wouldn't be able to serialize your entity, which you need in certain use cases. So what can you do instead? Well, you can apply a little trick. You can annotate your ID attribute with the ID annotation that tells Hibernate to use field access, which means it uses reflection to update the attributes of the entity. And when it uses reflection, it doesn't need any getter and setter methods, which basically means you can do whatever you want in the getter and setter implementation. And you can use it here, for example, to wrap the publisher into an optional when someone calls the getter method. So everyone who uses the book entity in this case directly sees in the at the get publisher method that this book might not have any publisher and that he needs to handle that in some way, and therefore gets back an optional. Another good change in Java 8 was the DateTime API. We finally got rid of the Java util date, or at least in some cases, because in JPA 2.1 it wasn't supported. JPA 2.2 is about, I don't know, a month, maybe 2 old. So for quite a while, the JPA specification didn't provide any support for the DateTime API. The reason was pretty simple. JPA 2.1 was released before Java 8. And it can support any data types that don't exist. Since Hibernate 5, you were able to use the DateTime API, and since JPA 2.2, it's also part of the standard, and it's easier and more comfortable to do than to use the old util date. You can see that here. It just takes an attribute of type local date. No annotations, nothing. Why? Well, that's pretty simple. With the util date, we didn't provide any information about what kind of data we stored in there. Was it a date? Was it a date with timestamp? With the new DateTime API classes, we have all these informations. We will use a local date to store a date, a local date time to store a date with time. So Hibernate already knows which information it needs to persist in the database. And that means that you can easily run this test case and just persist a local date for this book entity, and Hibernate just stores it as a date in the database. As I said, supported in JPA 2.2. If you're using Hibernate, you can use it since Hibernate version 5. In the earlier versions, it's unfortunately not available. But I know there are still several projects out there that use older versions of Hibernate, and you might not want to update it right now. But that doesn't mean that you can't persist classes of the DateTime API. It just requires a little bit more effort. You need to persist. You need to manage the data type yourself, which means you need to convert it into something that Hibernate knows how to persist in the database. And since JPA 2.1, you can easily do that with an attribute converter. Does anyone use an attribute converter in the daily work or projects? Yeah. It becomes more and more popular, and it's also the same way in which Spring Data in the beginning introduced support for these classes. And it's easy to implement. You just have to implement the attribute converter interface, provide the Java type that you want to convert and the data type that should be persisted in your database. And in this case, I took the easy route and said, okay, I map my local date to the Java SQL date. The good thing about that is, first of all, Hibernate knows how to persist the SQL date, and then the SQL date provides all the methods that I need to create an SQL date out of the local date and to create a local date out of the SQL date. So the implementation of the two methods that I need to implement for the attribute converter is pretty simple. The convert to database column just creates an SQL date for the provided local date, and in the other direction I create a local date with the toLocalDate method on the Java SQL date. So quick and easy implementation. You can of course do that for the local date time as well. And after you've done that, you can use this attribute. Oh, I missed one thing, the converter annotation. The converter annotation is another thing you need to do to register an attribute converter. You can either just annotate it with converter, or you can annotate it with converter and set the auto-apply attribute to true. In this case, setting the auto-apply attribute to true is a good thing because that tells Hibernate to use this converter for all attributes of type local date, which is most likely the approach you want to use for all data types that are not supported by Hibernate. So let's have a quick look at the test case. You can see here I just set the date of birth of the author as a new local date, and when you do that, you can see the insert statement here, and Hibernate then converts the local date to an SQL date, which means it called the local date converter, which brought out this log message. And if you select the entity again, then it of course does the conversion in the other direction. A nice detail here is you can also use this attribute in your JPQL queries. It doesn't make any, or you don't have to do anything else compared to a normal entity attribute. You can use it in the same way. Just reference it, maybe compare it with a bind parameter value, or just reference it in the select clause. Hibernate gets all the required information from the mapping definition and then uses the attribute converter to transform your bind parameter values and to also transform the values it got from the database. Okay, now we come to the only example for which I need a few slides. Who uses multi-tenancy? Okay, just a few. The general idea of multi-tenancy is that you set up one application that serves multiple independent customers. So typical example for that are SaaS applications that serve multiple completely independent customers. For example, if you have a CRM system, for example, then you might decide to use an online system, but you of course want to be sure that none other customer of that CRM system will see your specific data. So you need to separate the data of each client in some way. And there are 3 different approaches that you can use. The first of all is the separate database approach. So you use the same application for all customers, or for all tenants, but each tenant gets its own database instance, which means they are completely separated. They don't share any database resources. They store their data in independent databases. There will not be any impact if something goes wrong on one database node, and you can just, all other instances just continue to work. The second approach would be separate schema. So there you have a little bit less separation than in the separate database approach. With separate schema, you have one database, and each tenant gets its own schema. Each schema contains the same database tables. And in theory, there's a third option, which is discriminator-based. All tenants use the same database, the same schema, and there's an additional discriminator column in each table telling you to which tenant this database record belongs. Unfortunately, that's not supported by Hibernate, so you either have to use separate schema or separate database if you want to work with Hibernate. So how do you implement that? You don't have to do a lot to implement that. Let me close this. The only thing you have to do is you have to implement 2 interfaces. The first one is the multi-tenant connection provider interface, and the second one is the current tenant identifier resolver interface. So why do you need to implement these interfaces? The current tenant identifier resolver tells Hibernate which is the current tenant. Hibernate doesn't know about the user that is currently using your system. User management is not part of the job description of Hibernate. Why should it be? So you need to provide this information to Hibernate. And here I'm using a very simple approach. I've just implemented a setter method that I can call in my test cases. And then I store the tenant identifier within my class. In a real application, you would implement that a little bit differently. You would most likely get the current tenant identifier either directly from the from your authentication component that you use in your technology stack, so in your Spring Boot application or in your Java EE application server, or you might have stored it in the in your thread local, for example, by a servlet filter that was called when the REST endpoint was called and the user authentication happened. The second thing you need to implement is the multi-tenant connection provider. That's a huge interface with a lot of methods. In most cases, you don't need to implement all of them. You just need to extend this abstract multi-tenant connection provider class. If you do that, you just need to implement these 2 methods. GetAnyConnectionProvider is used internally just returns one database connection, doesn't matter which one. And select connection provider gets the tenant identifier that Hibernate got from our current tenant identifier resolver implementation, and selects the selects the database connection specific for that tenant. And in this case, I keep a map with the different connection provider. And you can fill that, for example, here in the constructor. The implementation in your application is most likely a little bit more complex than this one. Here I'm just creating new connections. When you're implementing a multi-tenant application, you normally have a bigger stack. That means you have connection pooling in place. And there you just request a connection provider from your connection pooling implementation for each tenant. Okay, so this part here is specific for my test setup. I have to provide the tenant to the current tenant tenant ID resolver. That part down here should look familiar to you. That's what you normally do in your application. You or the framework that you are using provides you with a Hibernate session or with an entity manager. Someone most likely started a transaction. And you are just implementing a little bit of business logic. In this case, I'm persisting a book with the title Book of Tenant 1. And down here, I do the same with Tenant 2. And as you can see, the first tenant identifier is Tenant 1, the second one is Tenant 2. So I now expect that I persisted a book for Tenant 2, a book for Tenant 1, and they don't see the book of each other. The good thing is, as you can see here, in the implementation of the business logic is that it doesn't contain any reference to the multi-tenancy. That means you can change your multi-tenancy implementation at some point without adapting your business logic. You could even add it after you implemented your application when you decide, okay, this tiny little application that works fine in-house will now be used for multiple independent tenants. So let's run this test and see what happens. Okay, so you don't see a lot in the log file. There are no information about the tenant that was currently used. Why? Because that happened all on the when Hibernate acquires the connection for the session, but not when you handle your use case. There it just selects the next value from the sequence, inserts the book, and does the same for the next one. So let's take a look at the database. Here you can see that's the database schema to which tenant 1 connected. See up here, at least I hope you can see that, it's tenant 1. And it only contains books of tenant 1. And the schema of tenant 2 contains only the books of tenant 2. So without adapting our business logic, and just by implementing these two interfaces, we added multi-tenancy to our application, at least to the persistence part. Okay, and who of you has to implement an audit log for the application? So documenting all changes that were performed by any user. Well, there are multiple ways to do that. You can do that with database triggers, or there are certain systems that pass the database logs and extract the information from there. And you can also use it do that with Hibernate Inverse. Hibernate Inverse is a Hibernate project that you need to add to your application. You can see that here. You just add the Hibernate Inverse dependency. And then you annotate your entity with audited. And that's basically all you need to do to implement a basic audit log for your application. When I now run a simple test case, like this one here, I persist the new book entity and then update the title. Then we can see in the log file, oops, and also in the database that Hibernate documents all the changes that we did. Where is it here? Okay, so we inserted a new book entity and then we updated it. So Hibernate selects a value from the sequence, inserts the book into the book table. That's expected. That is what Hibernate always does if we persist a new entity. And then it got another value from the sequence and inserted a record into the ref info table. This is the default revision table used by Hibernate Inverse. And Hibernate Inverse adds a record to this table for each transaction that did at least one change on an audited entity. And it not only added the new revision, which stores the timestamp and the ID of the revision, it also added a record to the book audit table. And this record stored the 3 attributes, publishing date, title, and ID of our book, has a reference to the revision, and also stores the revision type, which is an integer with 0, 1, or 2 as a value representing created, updated, or deleted. And when we now update the book entity, you can see that Hibernate performed an update statement, wrote an additional revision entry, and then added another audit record into the book table. And there you go. Just one dependency, one annotation, and you audited your entity. You now just need to add a few more annotations for all the entities you want to audit. And you can also use Hibernate Inverse to read data from your audit log, either vertically, which means you're looking at the changes applied to one entity over time, or horizontally, where you pick a certain timestamp and work on the data that was valid at that point in time. So you, for example, could go back to last Monday and have a closer look at what was the data on that day and what happened when you saw the strange message in the log file, for example. Okay. So we have a few minutes left for questions. For now, that's from my side. Who enjoys this format and wants to have more Hibernate tips? I wrote a whole book about that with 70 tips. And now we have 6 minutes left for questions. So who has a question?
Hello. I actually have 2 questions if it's not a problem. Let's say I have a table person and I have a connection table person has languages that has an indicator of mother or native language, and that I need to present all the persons with native languages in my system. What would be the best approach? Would it be to fetch all the persons, then to go with Hibernate initialize of the collection and filter it, or to create some DTO object directly in the query or something else?
The best approach would be to use a JPQA query for that use case. That especially filters all the person based on their native language. And then the interesting question is, what kind of projection do you use? If you want to perform or implement an update use case, you have to use entities as a projection. For all read operations, I highly recommend to use DTOs. They are a lot faster, and you basically get this performance benefit for free if you don't need to provide.
Just for the list. So
yeah.
DTO. Okay, and the second question would be with the auditing tables. Are they proposed to be untouched by the system, or I can create manually in database some information related with the audit entry or the audit table after it's created by the Hibernate, if you and some additional column in the table.
Yeah.
Can we add additional column? Can we add the additional column into the audit table for maintenance or something?
Yeah, you can definitely do that. I mean, in general, you should create your database tables with a script, most likely with a tool like Flybase or Liquibase, which does the version-based update. And Hibernate just connects to this database. And then you can do whatever you want with the database tables. You just have to make sure that the columns that Hibernate expects are there. If you want to have additional columns, that's okay. You could even implement your own revision entity and store additional information. You might have seen that in the log. By default, Hibernate, no, here. By default, Hibernate Envers just persists the timestamp and the revision ID, which is a good thing to start with, but in most cases you also need to answer who performed the change. So that only documents what happened when, and in most cases you also need information about who did that. And then you can implement your own revision entity, register it in the system, and Hibernate will use it. And you could, for example, store the username, user IP address, or any other information. Does it answer the question? Okay. More questions? Okay. Then thank you, and have a great rest of the conference.